This lesson is on proportional and non-proportional relationships. These relationships are really just number patterns. You could have a sequence that looks like this that may not necessarily be an arithmetic sequence. What you can do is you can take the difference and find that it may not be the same as the other differences. But these differences themselves may have a pattern. The pattern could be something like even numbers. The pattern may even involve variables. This pattern could really just be anything that you have to take the stretch to recognize. The best way of recognizing these number patterns you may find are to list the differences. Once you've listed a few differences, you can see if you can recognize any relationships. For the case of proportional and non-proportional relationships discussed in this lesson, these relationships will only be of the linear sort. All this really means, in a linear way, is that to go from one term to the next, you have to add something. And this something, in this case we say q, you can add again to find the following term. And if you look here for d3, we can also write this as d1 plus 2q. You should know what this means for all the following differences. Essentially, for these number patterns, if you have this sequence of A1, A2, A3, and A4, you can write the sequence of the differences. Once you write the sequence for the differences, you'll see that these themselves will have a common difference. The sequence of the differences is actually an arithmetic sequence for proportional and non-proportional relationships covered in this lesson. You should also note that in the case where q is 0, that means the sequence you started with is an arithmetic sequence. In other words, the differences between terms doesn't change, or there is a common difference. Now let's further investigate linear functions. Linear functions can be written in various ways, but they do have one common meaning. Let's start with a list of coordinate points. With these coordinate points, you can find the function that represents the line. But it's not immediately apparent how exactly you would go about doing that. We should start by thinking about what the slope is. It's often described as rise over run, but what this really means is that the change in the y value, which is the rise, divided by the change in the x value, which is the run, is the slope. This is very important. From here, you can see that using two coordinate points, you can find the slope. So now that we've found the slope, and x is just a variable, how do we get b? Well, you may recall that the way we describe this written form of a linear function is slope-intercept form. It's called slope-intercept form because m is the slope and b is the y-intercept. But there's also another form, point-slope form. This is how point-slope form is written. Y minus a y value is equal to m times the quantity x minus the associated x value. You might recognize the similarity between this and the definition of slope from the previous slide. Once you know the slope, all you need is some point, and you can determine things. So now, if you're given a few coordinate points, you can determine the slope and plug in the values you've learned into this point-slope form to determine the entire function for the linear equation. But what if you aren't given a set of coordinate points? What if you're given a graph? When we compare a graph with the equation of a line in slope-intercept form, we can make some good relations. So to start off with, we can immediately find b. B is the y-intercept, so we just look at this y-axis and see where the line touches it. And that is our value of b. In this case, it's -2. To find m, you may remember that slope is rise over run. So to determine that, you can pick any 2 points on this line. Let's just pick these. And you find the rise, which we go up 1, 2, and the run. So we go over 1, 2, and now we're at the point. So in this case, the slope is 1, and we've found the slope. So just like that, using a graph, we found the equation for a line. Be sure to check out the examples on this lesson to get a better idea of how all of this works.